Hey pre-calculus, welcome to our first video lecture of this semester. This is what the videos look like, me and a whiteboard, a world map, and occasionally Pikachu. I'm going to invite you during these videos to go against your instincts a little bit, to not just let this math happen in front of you. Pick up a pencil and take some notes. It's scientifically proven that what your hand writes, your brain tends to remember. And so the best way to start studying for this class is to just take some notes. All right, so let's get started on section 1.1, functions and function notation. And functions are certainly something that you must have learned about in high school, but we use them all semester long, almost all the time in pre-calculus and in calculus and beyond. So we want to make sure we get a little bit of a review and a good foundation going forward. All right, so what's a function? All right, I want you to think of a function like a machine. All right, so there's our machine, and the machine is going to use some kind of rule inside here to associate the input that we give it. So we're going to plug in some kind of input to this machine, and it's going to give us some kind of output. All right, usually we use X for the input in math and Y for the output. That's just convention. That's not a hard and fast rule. All right, but we are a little bit pickier about what we mean by a function other than just a rule that associates two variables together. So I'm going to give you a few examples of functions and then one that's not a function, and then we'll write down the definition of what a function is. All right, so usually our functions are equations. So this function, we're going to give it the equation y equals x squared. That's a pretty standard math function. All right, and we might give it the input that x is equal to 5. And then the function uses the rule to square it, and it tells us that y is equal to 25. All right, so that's an example of a mathematical function. Our second one, it could be something simple like a chart at a parking garage. So let's say we have a chart on the wall at the parking garage, and we tell it the number of hours. I mean, we're just reading a chart, but we look at the chart, we say the number of hours that we've been parked, and then it gives us the amount of money that we owe. That would be an example of a function. We could also say, what if calling up the registrar's office is a function for me? All right, so we'll see if we can fit the registrar here. Registrar. All right, so I might call up the registrar and I could give her your name, and then she could tell me your student ID. All right, so those are all good examples of functions. All right, let me change that last one and give you an example of something that wouldn't be a function. So if I called up the registrar, and instead of asking for your ID, I asked her for the email that you have on file. All right, probably the registrar has more than one email address for you on file, right? So the one that you've put on your application, and then you also have your PACE email in the computer. All right, so this one's going to give you possibly more than one output. Per input. All right, and if that's the case, you have a rule that might give you more than one output. This is not a function. Not a function. All right, so a function is a rule that associates with each input only one output. So let's write that down. All right, so let's take some mathematical equations and determine whether or not they represent functions. All right, so is y a function of x? And I give you an equation that has x's and y's in it. So to answer this question, first of all, we need to understand the question. When we say is y a function of x, we are always implying that the first variable that we state is the output variable. So this is the output variable, and this is the input variable. So it's important which way you say that. All right, so is y the output of a function of x? So to answer that question, you want to solve the equation for the output variable. Okay, so solve for the output variable. All right, so I'm going to solve this equation for y. I'm going to start by subtracting 2x from both sides. That gives me 3y left on the left and 5 minus 2x, or negative 2x plus 5, however you want to write it. And then to solve for y, I divide by 3. All right, so y equals 5 minus 2x over 3. And this just makes it easier for us to think about that definition. So remember that a function gives you only one output for every input. So imagine you're plugging in some kind of input for x. So maybe I'm plugging in the number 10 or -5 or something. The next thing you would do is multiply it by -2, and then you'd tack on that 5 and then divide by 3. But none of those operations that I'm doing are suddenly going to create more than one number, right? I'm just going to do 2 times 10. I'm going to do 5 minus that, divide by 3. So you're only ever going to get one y value by plugging in one x value into this equation. So this does qualify as a function. Let's try another one. All right, so this one, x times y is equal to 5. This is much easier than the last one to solve. Remember, y is the output, so we're going to solve for y. And I get y equals 5 over x. And again, if I'm going to plug in a number for x, 10, I'm just going to do 5 divided by 10. That's never going to give me more than one y value for each x value. So this also is a function. All right, let's see one of these where this doesn't work out. So how about x squared plus y squared is equal to 9? We're going to do the same trick. We're going to try to solve for y. So I'm going to subtract x squared from both sides. And I get y squared equals 9 minus x squared. And I need to take the square root of both sides to get rid of the square on the y. All right, and hopefully you remember that when you take square roots of both sides of an equation, you always need to put a plus or minus on the square root. Okay, and that's just because if y squared was equal to 16, I mean, y could be either 4 or -4. You could square both of those and get a positive 16. All right. So you always have a plus or minus on there. And that plus or minus really is the problem and why this equation is not a function. Okay, so if I'm going to take some value for x here, whatever it is, plug in 1, then you're going to do 9 minus 1 squared, take the square root, and then you're going to put a plus or a minus on there. That's going to give you two different values for y, one with the positive square root and one with the negative square root. So you're getting two outputs for every input. So this means that this is not a function. All right, so figuring out whether something is a function from the equation is actually a lot harder than figuring it out from the graph. So I want to graph these three equations that I gave you on Desmos and show you how you can just tell by looking at their graph. All right, so here we are in Desmos. We're going to take a look at these three equations. I'm going to start off with 2x plus 3y equals 5. Desmos doesn't even care that you don't have this solved for y. It'll just graph it for you. And remember that the definition of a function is that for each x, you're only going to get one y. So for each x coordinate, you should only have one y coordinate. All right, and you can see like any x value that I pick along the x-axis, I'm only going to find one y value associated with it. A good visual way to see this is to kind of mentally, or in Desmos, I can do it visually, draw a vertical line and just kind of slide it down the graph. All right, so as I'm sliding this vertical line left to right, you can see that for each x value, I'm only hitting that line at one y value. All right, and that vertical line is just kind of testing, does each x get only one y? All right, so let's try this for the next one. We found out that this one was a function too. So as I drag this vertical line along, I'm only hitting one y coordinate. This graph has kind of a bizarre break in the middle where it kind of freaks out and doesn't want to touch the y-axis, but whatever. But any place that I do have graph, I can see that I'm only hitting each x coordinate getting one y coordinate. All right, so let's turn on our third one that we found that was not a function. All right, so this one ends up being a circle, and a circle is perfectly good shape and a perfectly good graph, but you can see that each x coordinate here is getting associated with two different y coordinates, one on top of the circle and one on bottom of the circle. So this fails what we're going to call the vertical line test, and this is just a way to spot check looking at the graph whether or not you're looking at the equation of a function. All right, here's our vertical line test officially written down. If any vertical line intersects a graph more than once, like on our circle, that graph is not a function. So now we can identify whether or not an equation represents a function by looking at the equation and solving for y, and by looking at its graph using the vertical line test.